Okay, now, on the previous, I should say, tutorials, as we discussed about the mechanism that we are just gonna use it in order to fit our first Bayesian model. In order to do that, we are just gonna start with a very basic example. I assume that by now you have just installed the package rstand-arm, and you just have it ready inside the library rstand-arm. And now we are just gonna start our first model. In the model that we're just going to use, we are just going to start first by uploading the datasets. I'm just going to use the only a single variable, the Bayesian linear regression at this stage. I'm going to expand it into multivariate Bayesian regressions in just a couple of tutorials ahead. But at this stage, in order to just go ahead, I'm just going to use only a model which incorporates one variable or covariates. And it's going to be as what you have seen. It's going to be either our weight or it's going to be either our height. The dataset is going to be a woman. And now I'm just going to just use the datasets in order to just fit my first model, which I'm just going to call that stand GLM. It's going to be the function which is embedded inside the package rstand-arm, which is going to be somehow similar to the GLM functions that we have used that in the past. What we have done in the past was, if you remember on, I'm going to go to the next page, we have two different functions, which I'm just going to more talk about them. One of the functions that we had before, it was the GLM function, which it was the generalized linear models function. And also the one which we're just going to use right now, it's going to be stand GLM, which is going to be the stand generalized linear model, which is the Bayesian versions of the non-Bayesian GLM which we used in the past. Very quickly, I'm just going to use a simple comparisons between them before we just move on. With the GLM methods that we used before, the thing which is that the algorithm that we just use, it's essentially it's the maximum likelihood estimation, which is the algorithm in order to just run the GLM methods into the non-Bayesian context. However, for the one which we are just going to use right now, for the stand GLM method, there are a variety of algorithms that we're just going to talk about that in the next couple of tutorials. But one of the basic algorithms that it's a kind of a default inside this function stand GLM. This is MC or a very fast version of that, which is going to be Hamiltonian Monte Carlo, which is going to be the algorithm, which is going to be the default for that. However, as you will see on the next tutorials, we may just have to use the optimizing, or we just may have to use, I should say, mean field or full ranks. There are a variety of algorithms. We're going to talk about them in just the next couple of tutorials, but you assume that one of the basic and one of the most important differences between, I should say, these two algorithms is essentially between these two functions, between the GLM functions and the stand GLM functions, is essentially the type of the algorithms that they use in order to just find the answer for as an estimate for our statistical inference for our model. By just that very basic introduction, and saying that, then as a result, if I just go back to that, but except from the algorithm differences that they have in most of the syntaxes which they have between the GLM method and the stand GLM method, there is a striking similarities between these two functions there. Okay. Now I'm just going to run my first model. In the first model, before I just run, I'm just going to go ahead and just use the F1 tab in order to see the arguments which I have to just incorporate to this model. I'm just going to start with the basic arguments there. Then as we just move on the next tutorials, I'm just going to add more and more arguments and show you the impacts that they have on the inference that you're just going to make them. Okay. The very basic, I'm just going to start with the basic arguments. The basic arguments, as you will see on the functions as on the help menu there, it's going to be the formula. The formula, I'm just going to come here and say the height is going to be a function of the weight, and that's how we just represent that in the R. We show the tilde, which represents the function. It shows that the height is a function of the weight. On the next line, the other crucial thing that I have to just use that in order to run my model is going to be the data. The data which I'm just going to use is going to be the woman data, which I'm just going to use. With these two basic, I should say, arguments, I can just go ahead and just run the model which I want. However, before to just execute this line, I'm just going to just store that into a name. I'm just call it model A, and I'm just going to store the model into an object which I just call that model A, only with two arguments, the formula and the data, which is exactly the same syntaxes that we had to just use that in the non-Bayesian context when we had to just run the generalized linear model. In the non-Bayesian frameworks, you see there is no difference. However, for a default one, I can just write the algorithm, which I'm just going to just put the sampling, which is a kind of a default algorithm for the stand GLM method. If you even do not write that, it is assumed that you're just going to use the sampling using dynamic, I should say, Hamiltonian Monte Carlo. But in order to show a bit of the difference between the stand GLM and the GLM, I'm writing the default algorithm, which is a sampling Hamiltonian Monte Carlo. I can just go ahead, execute this model, and store the whole model, I should say, option into an object which is called model A. I'm just gonna press Control Enter to just run this model, and you will see that the model right now is stored into the model A, and that's the stand generalized linear model which we expected to just have for this tutorial. In order to see what are going to be the specificity of this argument of this model on the next tutorials, we are just going to talk about that. What did we get, and compare that with the regular non-Bayesian GLM model.